So this free response problem definitely had the most issues of the ones that I've gone over, so I definitely wanted to post this first. Be looking for other solutions attached to various assignments as we work through them. So let's start here. We have our graphs, and part A actually went pretty well, so I don't want to pretend it was all rough, but there's a couple places that we can definitely improve on. So we've got our two functions here. We have f of x, which is this lower one down here, and then we have g of x, which is this upper bound here, which I can tell, even though this isn't a calculator problem, just because I know the behavior of cosine and I know the behavior of e to the x. And then we have our vertical bound at, whoop, it's a little cut off here. There we go. At x is equal to pi over 2, which is this section here. Right, but don't evaluate the area of R. So the area of R is just the area between these two curves. So from the upper limit, which is e to the x, down here, and most of you did just fine on this, the x values are 0 to pi over 2, and then upper bound minus the lower bound. Some of you put parentheses around here, that's just fine. For the few of you who turn those around, then your answer would be negative, but it's an area. So if you want to have cosine first, because I did say it doesn't matter, but it only doesn't matter if you put the absolute value around them. So this would have been the other final answer that I would have accepted. Okay, this is definitely the main one that had a lot of issues that were more easily avoidable. C was just really hard. The first issue that's easily avoidable was it's not specifically a calculator problem. You can absolutely use a calculator to check your work, to make sure you're on the right track, all those things. But you still need all the work that you would need to find the volume. Then the other one of this is, yes, A and C are just asking you to write the integral, but B actually did want you to find the answer. So you have the two different curves, and when we're finding them rotate around, what most of you correctly said is that it's the first one and then minus the inner one when we rotate around the x-axis like this. But then the main thing here is that it's the big R minus the little one. So if we're looking at just the generic formula, it's the integral of big radius minus the smaller radius. So you'll notice that they're separate squared, not squared together like this. And then of course, since we're talking about circles, it's pi r squared, and I just put it out front like that. So same thing here, big R is going to be this outer bound, so it's e to the x, and the inner bound is going to be root cosine of x. So there's two issues that I noticed in this next step that we're about to do. The first issue was that this is not a calculator problem, but a bunch of you just jumped to doing this on your calculator right away. A calculator is a great tool to check your answers with, but unless it's specifically a calculator problem, you still need to show that work. The other issue was e to the x squared. These two are going to multiply together, and this term is going to be e to the 2x, which is great because it's much easier to integrate that versus e to the x squared, which is what some of you did. But if you simplify this, you end up with a thoroughly reasonable integral. I'm going to keep the pi out front, and then it's 1/2 e to the 2x, because we're just dealing with the coefficient created by the chain rule, minus sine of x, and still from 0 to pi over 2. And from here, it's a little bit of arithmetic. Sorry, I ran out of space a tiny bit there, but we end up with pi over 2 plugged in here, minus 0 plugged in, e to the 0 is 1, so that's just minus 1/2. And then sine of pi over 2 becomes 1, and that's how you get the correct final answer which I wrote as pi times 1/2 e to the pi minus 1.5, but obviously there's lots of different ways that you could have written that answer. And I think the decimal form is like 31 something, but again, this is not a calculator. You're looking for an icon of a calculator on those, and so I'm still expecting you to show your work all the way through, and you can just check it on a calculator. Right. Last one here, part C. Region R is the base of a solid. And so one thing I noticed that a couple of you who got some points on this is that, we've got a rough sketch in of our curves, and then this is our semicircle. And so if we're talking about the area of a semicircle like this, we're talking about 1/2 pi r squared times dx. And this r is the distance here divided in 2. So here we're looking at pi times 1/2 pi times, let's see, the upper bound is e to the x minus the lower bound root cosine of x, and then the radius, so it's just half of that, squared dx. And this is then the integral that you would want. Obviously there are plenty of equivalent answers that you could have put in. You could have brought these outside, you could have simplified this a bit farther, but this was all you needed to have here for your answer, was just writing the integral. So this is definitely one of the harder ones that we did this week. I'll post answers of the rest as I get to them, and hopefully this has been helpful for a lot of you. You can ask me more questions in the comments or by email or on Zoom. Just let me know where you got stuck.